This is how these two Stanford PhD students leveraged a simple algorithm to create all of this. To understand their breakthrough, we need to go back to the early days of the internet, more precisely in 1996. People were jumping to the Macarena, cheering for Michael Jordan's Chicago Bulls, and popping VHS tapes into their VCRs. But online, things were frustrating. Search engines existed, but they often provided you with irrelevant results. And why was that? Well, it all came down to how search engines relied on matching keywords to rank pages. Take a simple search like pizza in New York. The two main keywords being pizza and New York. Ideally, the search engine will show results where the words pizza and New York actually match the content of the websites. This was when website owners started stuffing their web pages with popular keywords to trick search engines into ranking them higher. But you know who else is an evil content creator? Me. But instead of stuffing random keywords, I'm just asking you to like this video, subscribe, and hit that bell button. Anyway, back to our internet search. The situation was so bad that the results from your search would most likely end up looking like this.
It's time to stop!
That's also probably what Larry Page said to the other Google co-founder Sergey Brin moments before creating PageRank. But what is it, and how does it work? What the creators realized was simple but profound. If a web page has lots of other pages linking to it, it is probably an important one. To make sense of this, think of the web as a graph. Each node represents a web page and each edge represents a link from one page to another. The more links pointing to a web page, which in our case are edges pointing to a node, the more important that web page becomes.
So in this example, can you see which page will be the highest ranked one? Will it be node 1, node 4, or node 5? Node 1. Muy bien.
So, now that we have a good ranking of all pages, we can wait. Why is node 2 now ranking first? Did someone just boost that artificially, maybe by creating an artificial network of web pages linking to node 2? Yes, they did.
How can we address this?
Said Sergey Brin to Larry Page.
What about we implement a system in which not all links are created equal, so that links from a high-quality, trusted page carries more value than a link from an unknown or unreliable page?
And that's what they did.
For example, in this situation, web page 6 is the highest ranked page with the most links. Will page 3 have a higher benefit in terms of ranking from an incoming link of web page 6 or from web page 2? The right answer is web page 6. Muy bien.
Great, but how can we know the importance of a web page if its importance depends on the importance of other pages?
Let's run a simulation of a user browsing the web and count how many times it lands on each page.
Said Larry Page. And that's what they did. This is also known as a random surfer model, and by tracking how often the user lands on each page, we can determine rankings based on the percentage of visits each page receives. But how does it work in practice? The user begins on a random web page and navigates by clicking links from one page to another, tracking how often each page is visited. These pages are then ranked based on the percentage of visits they received. Pages with more incoming links naturally receive more visits. Additionally, since these high-ranking pages draw more traffic, the pages they link to also experience an increase in visits. But there are also pages on the internet that are not connected through links. Let's take for example this graph. The user will keep following the same 3 links in an infinite loop without providing a real measure of the page's importances. To account for this, they introduced a damping factor, commonly set to 85%, which represents the probability that a user will follow an available link on the current page rather than randomly jumping to any other page on the web. Now, every time the user needs to move to another page, it will either follow the available links 85% of the times, or jump to a random page 15% of the times. So, now that everything is set, we are ready to see if our new incredible search engine does a better job than our keyword matching search engine. Let's take as a final example our previous query, pizza in New York. And suppose there are 5 web pages related to our query. But one of these pages is completely unrelated. Like a page about tennis which has been stuffed with the word pizza in an attempt to artificially boost its rank. Then we have an article about the best pizza places in New York and 3 different pizza spots, one of which being so good it's also referenced in the website of the other 2 pizzerias, like in this graph. Now let's compare the 2 search engines. In the keyword-based search engine, the best pizza place ranks the lowest while the tennis page ranks first, simply because its website is stuffed with pizza-related keywords. But on our new incredible search engine, after several iterations with PageRank, the best pizza spot ranks first, while the tennis page performs poorly and ends up ranking last. PageRank was revolutionary in transforming the way search engines ranked web pages, but as the internet continued to grow, so did the need for more sophisticated algorithms. Today, innovation like AI-driven models, user-focused algorithms such as Google RankBrain, which we will see in a separate video, have taken search technologies to new heights. But we can still appreciate how a simple idea like the one behind PageRank can have such a drastic impact on our world. Thank you for watching. If you enjoyed this video, subscribe and see you next time.